so we're going to go through this work. This is what I've set for year 10, for year 9s to start year 10, and for my year 8 group. Just because it's very similar work, so I thought, right, I'll share it out. So, the idea was, when I set this work, what I wanted you to do was to really either download it and print it off, or really download it, not edit the version that's online. And perhaps what I'll do is I'll go through some bits and pieces towards the end of the video about this work going forwards, just to help people out and to sort things. So, right, starting off then. So the booklet then. Let's get rid of the first page. Don't do the first page. So this is our review checklist. On this page, all this is about is for you to check your learning so far, to review what you know before we start. So put B's in the boxes, like so. So you read it here. The symbols of components, cells. So if you know what they are, brilliant. You put a B in the big smiley face box. You're happy with that one. Series circuits in which current is the same throughout and voltages add up to the supply voltage. Well, for this one you might go, well, I'm there. And the idea is this gives you an idea of how far you've come, but it also gives me an idea, if I have a look at it, where your gaps are. Okay, so on to this work then. Right, the next page, some helpful videos, loads of links. If you've got this set up in online, obviously they're clickable, otherwise you'll have to type them in. The main one on here that is going to be vital for us doing work is this one down the bottom, which is a link to a YouTube playlist, which has loads of help videos on how to do the investigations that are in this. Okay, so first things first, WJC requires you to know the following components. Says do your own research into the function of each component. So what I want you to do is you go on to the internet or books or wherever, and you do your own research into this. And what you do is you research what each one does. So our switch. Obviously switches, they control the flow of current. Okay, and the idea of these is obviously switching them on, switching them off controls where current can flow. Just remember, I've got in front of me the live chat, so if you've got any questions as I'm going through this, put them in the live chat, and I can see what's going on. Alright, so remember, put your questions in here. And that way then, I can see and answer, hopefully I'll answer specific questions. Alright, so our lamp, obviously lamps, they just turn electrical energy into light. Okay, right, our cell or our battery. Alright, so cell or battery, what does that do? Well, a cell or a battery into light. Now, our cell or battery, this is our power source. Whoops, the microphone's just fallen over. So this is our power source. This is where our source of energy comes from. Alright, so our cell is our energy source. It converts, if it's a cell, converts electrical energy into, chemical energy into electrical energy. Now, our fuse, these blow if too much current flows. So we've got a question. Do we write the answer next to the symbols? Yes, please. Just like I'm doing, you can write them random. That will do for this. If you're doing it on a Word document, you might need to put word boxes to get it specifically next to these. So yeah, fuse, these blow if too much current flows. Right, diode. Diode allow current to flow in only one direction. Alright, so they're used quite a lot in electronics to make sure current doesn't flow in the wrong direction, damaging components. Okay, the voltmeter then. Voltmeter measures voltage. And these must be in parallel. Yeah, must be in parallel. Resistors. Now resistors reduce the current. So adding a resistor in a circuit is always going to make the current lower. Right, the ammeter measures current. And these will be in series. Variable resistor, value can vary. Alright, so variable resistor is like a fixed resistor, the one above, but rather than having a fixed resistance, we can change its resistance. These are things like dimmer switches. The volume control on most devices is a variable resistor. Okay, right, thermistor. Thermistors are temperature dependent resistors. Alright, so thermistor, temperature dependent resistor. LEDs, these are diodes that emit light. Which just means they give out light. LED, light emitting diode. And an LDR is a light dependent resistor. Now these two, a thermistor and an LDR, allow us to get circuits that actually react to their surroundings. And we can use them in that way. Alright, so the AC power supply then. So AC power supply, AC stands for alternating current. And these three down here can all be used instead of a cell or a battery. So an AC power supply is alternating current, shown by the little squiggle. Alternating current means the current is flowing backwards and forwards 50 times a second. DC power supply, direct current. This means that the current flows the same way all the time. It doesn't vary. So this is very similar to a cell. An available DC power supply, this is just one where we can change the voltage. This one here, DC power supply, we would talk about the voltage being fixed all the time. A variable power supply means that we can change voltage. This is effectively what we use in school. Those power supplies we use in school are one of these. So if we're ever drawing a circuit properly with these in them, that's what we should use. Okay, on to this next page. Now, depending what Word version you are using, this page looks slightly different. It's meant to look like this. What I didn't think about when I did this was that the blanks, the way I do it is I just type the words in the blanks and go from there. However, what I didn't realise was that by doing that, if I just did it on the online version of Word, the words would just be there and it makes a bit of a mockery. But if they are just there and you're doing this online in that way, what you can do is just highlight them and change them back to black and the words are there. So, using YouTube or wherever, fill in the blanks about voltage and current. So, electric current is the rate of flow of electric charge. Alright, so if you're doing this online, you could just highlight that word, change it back to black, and it will just say charge. No current can flow if the circuit is broken or incomplete. Again, just highlight it, you can change the words there. When a switch, for example, when a switch is open, so open switches break the circuit. It is measured in something that's symbol A, so that's amps, with a little a. Ammeters must always be connected in series, we said that before. In equations, we give it the symbol I. So we don't use a C for current, we use an I. Blame the French. It stands for intensity du courant, so that's where it comes from. Tea on my glasses. Right. Something which is also called potential difference. So voltage which is also called potential difference, is how much something each unit of charge has, how much energy each unit of charge has as it goes around the circuit. It is measured in volts by a voltmeter. Voltmeters must always be connected in parallel to the component you are measuring. In equations, it is given the symbol V. So we use V for voltage, I for current, V for voltage. Okay, so series circuits only have one loop. For the current to return to the power source, it must go through every component in the circuit. Parallel circuits have more than one loop. For the current to visit every component in the circuit, it has to travel through the power source more than once. Now it is time for your first investigation. Go to this website, follow the instructions on video 1 called Series and Parallel Circuits, complete the following investigation. So the idea was here was that you'd follow that link and you would open up this software, FET. Eventually you'd get to this, and then the other thing you would do is you would follow the YouTube link for video 1, and that would give you the instructions as to what to do. Okay, so in this lesson you will investigate the current and voltage in series circuits. You will measure these using an ammeter and a voltmeter. To do this, you will need to set up a series circuit. Start by constructing this circuit. So we construct that circuit in FET. So what we do is we take, well, we've got 3, so we could have 3 batteries and 1 bulb, like so, and we can make it draw our circuit. Now, if you want to work in symbols in FET, you can do. Let's have symbols. There we are. There's our symbols. And we have our circuit flowing. Next, you will need to measure the current in different places in the circuit. To do this, you need to place the ammeter in the circuit at each of the places shown in this diagram. Alright, once before the bulb and once after it. Record the readings on your ammeter. So we take our ammeter, we break the circuit, we want to put it before the bulb, so we put it before the bulb, and we get 2.7 amps. And then we want to place it after the bulb. And we get 2.7 amps. Okay, so we've done that bit. Now investigate the that should say difference. When you add a second bulb to the circuit, you'll need to use the ammeter in 3 places this time. So, we're going to add a second bulb into our circuit. There's our second bulb. Okay, currently I've got the ammeter in between the two, so that's this one, ammeter 2, 1.35. And then we place the ammeter, we remove the ammeter from there. And we connect our bulbs back up, like so. And we can place it here. That's also 1.35. And we can remove our ammeter from this bit of the circuit, join it back up, put it on here. And this will also be 1.35. Okay, so let's have a look at our results. Back again, threw my paper on the floor. Let's have a look at our results then. Let's sum it up. So in this one we had 2.70, in this one we got 1.35. So what we found out about the current in a series circuit? Well, the first thing we found out is that adding more bulbs lowers the current. And that also the current is the same everywhere. Alright, so what we found out about current in series circuit, adding more bulbs lowers the current, and the current is the same everywhere. Alright, so that's series circuits. Alright, so now we look at voltage. Alright, so voltage is a measure of potential difference. Tell us how much push is left in a circuit at any point. To measure this, we find the difference in push between two parts of a circuit using a voltmeter. Where I'm up to. Because the voltmeter compares the push in two different places, it must be placed in parallel across the circuit. It does not form part of the circuit. This diagram shows how a voltmeter is connected across a single bulb. Next, you will need to measure the voltage in different places in the circuit, so we can get rid of the ammeter. Just neaten our circuit up a bit. And we need a voltmeter. Alright, place the voltmeter in the circuit at each of the places. So V1 is the two leads across this first bulb, like so. And we get 13.5. And V2 is across the second bulb, like so. And we get 13.5. And V3 is across both bulbs, and we get 27.0. Okay, so what have we found out about voltage? Well, if we do 13.5 plus 13.5, we get 27.0. So, in a series circuit, voltage is shared by the components and the total voltage across all components is the same as the supply. Alright, so in a series circuit, voltage is shared by the components and it is the same as whatever is supplied. Okay, parallel circuit then. So we're going to make a parallel circuit. So let's get rid of what was on there. Let's put back in our three things. 1, 2, 3. We're going to have two bulbs in parallel. Let's do it with the pictures this time because I think it looks nicer. So we've got our parallel circuit. Let's get it working first before we put our ammeters in it. so we know we've got everything hooked up correctly. So, one bulb working, two bulbs working. So we now got our circuit working, parallel circuit. Okay, so what we're going to do, measure the current here. Now, what we can actually do here is let's put all our ammeters in at the same time. So, ammeter 1 goes there. Ammeter 4 goes there. Ammeter 2 goes there. And ammeter 3 goes there. So, ammeter 1, 5.40 amps. Ammeter 2, 2.7 amps. Ammeter 3, 2.7 amps. And ammeter 4, 5.0 amps. So here, if we add this to this, we get this top one. Alright, so this gives us our rules for parallel circuit. So, in our parallel circuit, current splits along the branches. So we call each one of these where we have a split, we call them branches. So these are our two parallel branches, so the current comes down here, all the current comes down here, some goes this way, some goes that way, so it splits along the branches. The total current flowing out of a power source equals the total through all the branches. Right, just going to leave that there a minute for people to write that down. Okay, so parallel circuits voltage then. So voltmeter, let's put our voltmeter, so we've got our circuit set up as per that top diagram, as per here, we got this circuit set up. So we're going to measure the voltage. We're going to measure the voltage across all three cells. Measure the voltage across all three cells. V1, we get 27 volts. We measure the voltage across the top bulb. We get 27 volts. We measure the voltage across the bottom bulb. Put it in the right place. We get 27 volts. Okay, so what have we found out about voltage in a parallel circuit? So in a parallel circuit, the voltage is the same across two components in parallel. Alright, so two components in parallel, the voltage is the same. Now, the next bit that's on this is resistance. And what I plan to do is I'm going to do another stream totally on resistance. That'll be next Tuesday. That'll be mostly aimed at year 9s, going into the GCSE. Year 8s, yes, by all means, if you want to watch it. But I don't think this is in your video. So, what I want to talk about now is some things to help you, because lots of people are saying about help, and they were struggling with stuff, and I just want to go through how to access these workbooks again, just so people can see it. So, things to help you then. Alright, so some websites. So this gentleman, Lewis Matheson, was a head of physics, might have been head of science in a private school down in Bristol. He's decided to give that up, and is doing solely YouTube videos now. And what he is doing is doing lessons on the GCSE work, basically. So if you look at this video, this is in the description. I think the channel's in the description, but this is the video I'd suggest you watch. This is giving you the timetable of what he's going to do each day, and you can see that he started off with kinetic energy. Kinetic energy for us isn't till year 11, but you can have a look at the electrical circuit videos. There's different bits and pieces on there. So that's a really good website, dead simple. He explains things really well. In the live ones, that means that obviously you can ask him questions like you can do here if you choose, but we've not had many questions, which is fine. Don't forget as well, in terms of Educate, people need to be doing their Educate quiz. So you can see that I've only had 6 people in year 8 do theirs, and of all of year 9 I've only had 2 people do theirs. Now the year 9 one is for more for end of topics, so I don't expect so many people to have done the year 9 one. As you can see, the date they've got is quite a long date. Year 8, you've only got really till Thursday, then it's starting to be late. Anybody who gets, what shall I say, 80%, anybody gets over 80%, I'm going to give some house points to on them. For year 10 now, for year 9 into year 10, this website, Isaac Physics, link is in the description again. What this is a website that helps with questions, and I think my camera's just switched off. Let's switch my camera back on. Right, I know you can't see me at the minute, but I am just getting that back. Okay, so it's maybe really small. And cut me off in a weird way. Interesting. Oh, that's because that was like full screen. There we are, that's why it's maybe really small. Okay, so anyway, I'm back again now. Excellent. Right. So this website, like I said, is designed really for A-level. But if we go down to difficulty 1, you can see pre-AS, that's GCSE. We can do some general circuits questions, light bulbs, so we've got some different questions to do. Some are multiple choice, some are, oh, that's another multiple choice one. Some require you to do calculations. And all of them, that's what's there. That's there to help you practice sort of exam style questions that are not on Educate. Right then, the other thing I want to talk about was these documents then. So, log into Office 365, and if you go into Teams, either the email I've sent you, or if you go into Teams, you will see, when it loads up, that your teams, let's get into Teams, you will see the teams that you are a member of. So I've done one, as you can see, Y1, Y2, Y3, X1, X2, X3 for year 9, for year 8 is here, so this is my year 8 class. And what I'll do is I will post the files up that you need in these teams. So, files, the file is gone, that's handy. Alright, I will repost the file that you need. Let's just put that file in now for you. What I'm going to do is I'm going to put it as a PDF this time. so you will have to download it. So anyway, the file you'll need is there, and you can open in the browser. You can download it. Let's put the Word document as well. So that should have year 8. I don't know where your document's gone. Obviously someone's deleted it, which was handy. So let's put the work back in for year 8. That's why you couldn't find it. Makes a lot of sense now. So re-upload that. So that's there now for year 8. In terms of its permissions, what I am going to do, or what I will do, is I'll change its permissions so that people can't edit it here. But what I'd like you to do, yeah, you can open it up in the browser, or you can edit in this. Personally, I think far better to download it, and then you could always re-upload it to this with your name on it, so I can see the work that you've done. For year 9, if I show you the year 9 one, let's go back to Teams. For year 9, task 1, files there, plus all the videos on how to do the practicals. Likewise, again, don't edit it here, download it, share it, because you can see the problem with doing it on here is some things have moved around, which is a pain. If you download it, then they've not moved around. Okay, so yeah, basically guys, thanks for watching. Stay safe, and like I said, keep doing it. When you've done sections of work, if you want me to check them, upload them, email them to me, take photos of them if you've got them in printouts, whatever way you do, that is fine. And like I said, to just keep, let's just get a photo, let's just check me, just me, that's too big now. So let's get rid of those two. Yeah, so yeah, just keep uploading your work, keep doing the work, keep following us on things like Twitter for more information, and if you do get stuck, yeah, please do email me. But don't just say I'm getting stuck on everything. Say I can't do this little bit, and then I can go through that. All right. Like I said, thanks for watching, and I will see you this time next week.